Hello and welcome to Kognito Key. Have you ever wondered how developers manage to build those huge, complex apps we use every single day? How do they do it without the whole project just collapsing under its own weight? Well, that's a huge question for any software developer, and today we're going to explore a really elegant solution. It's called functional decomposition.
Just think about it for a second. Your banking app, a food delivery service, your favorite social media platform. These things are massive systems with hundreds, maybe thousands of features. So how on earth do developers keep it all straight? It's definitely not magic. It's a very clever method.
And that secret is a really elegant technique for taming all that complexity. It's called functional decomposition. And honestly, it's all about making big, scary problems feel small and manageable.
So what is it exactly? Well, think of it as a top-down approach. You start with the entire system, that one big, intimidating problem, and you just systematically break it down into smaller and smaller pieces or modules based on what they do. You keep going until each piece is simple, clear, and totally manageable.
And here is the most important principle to remember. At the beginning, you don't worry about the nitty-gritty, the code, or any of the technical details. Nope, you focus only on what a function needs to do. The how, the actual implementation, that comes way, way later.
So how does this actually work in practice? Well, the great thing is it's a very structured process, which gives us a clear roadmap to follow. So let's walk through the steps together.
Okay, here we go. Step 1 is all about getting your North Star. You just define the software's main purpose in one simple sentence. That's it. For step 2, you start listing out the big, immediate tasks needed to achieve that main purpose. Now, step 3 is where the magic really happens. You take each of those tasks and you break them down again. And you just keep repeating this until the pieces are as tiny and simple as possible. And finally, step 4. This is your sanity check. You review the whole map you've created, the functional decomposition diagram, just to make sure nothing important was missed.
Now, I know that might sound a little bit abstract, so let's make it real. We're going to use this exact method to design a simple app for booking a doctor's appointment. This is a perfect way to see the process in action.
So here's our step 1. What's the one-sentence mission for our app? Simple. Make an appointment with the doctor. It's clear, it's concise, and it's straight to the point. This is the very top of our pyramid.
All right, on to step 2. We ask ourselves, what are the main things a user needs to do to make that appointment happen? Well, they'll need to register, of course. They'll need to search for a doctor, manage the appointment time, actually book the slot, maybe view their past records, and finally handle the payment. These become our first level of subfunctions.
Now for step 3, the refinement. We're not going to break down every single one of those right now, but let's just pick one. Let's take that very first one, register yourself, and see what smaller pieces it's really made of.
And here we go. You see, the register yourself function can be broken down even further. First, a user has to open the app. Then, the system has to figure out if they're a new customer or an existing one. If they're new, they'll need to enter their details and create a login. If they're not, they'll just sign in with their email and password. See how we went from a big idea to very specific, concrete actions? You just keep doing this for every single subfunction.
Okay, this is where it gets really clever. You see, not all decompositions are created equal. There are 2 key principles that separate a really robust, beautiful design from a messy one. Let's look at what makes this process truly successful.
So the 2 big goals here are strong cohesion and weak coupling. Strong cohesion is actually pretty simple. It just means that everything inside one function should be highly related and focused on doing one single task. Think of a kitchen drawer that only has spoons. It's simple, and you know exactly what it's for. Weak coupling means that all your different functions are as independent from each other as possible. This is absolutely crucial. It's like having separate electrical circuits in your house. If one fuse blows, it doesn't plunge the entire house into darkness, right? The rest of the system just keeps on working. That's what you want.
So why go through all this trouble? Well, because the payoff, in terms of clarity, efficiency, and just the quality of the final product, is enormous. Let's quickly summarize the key benefits.
First, any complex system becomes so much easier to understand when you break it into these small logical parts. Second, finding and fixing bugs becomes a quick, targeted process, not some wild goose chase through thousands of lines of code. And finally, this method forces you to think so clearly about what each part of the software needs to do, which results in much better, much more precise requirements from the very start.
And this brings us to a final thought. This way of thinking isn't just for software. Planning a big event, launching a new project, even writing a book, they're all complex systems at their core.
So what's a big problem in your life that you could tackle by breaking it down into smaller, more manageable pieces? It's a really powerful way of thinking, isn't it? If this explainer helped you see complexity a little bit differently, please do hit that like button, share it with a friend who might find it useful, and of course, subscribe to Kognito Key for more deep dives into the big ideas that shape our world. Thank you so much for watching.